In this problem, we are given a contour map with the contour lines labeled with values. And then we're given 2 points. And we're asked first to estimate the function value at these 2 points, then to draw a vector in the direction of the gradient, and then to say which gradient is going to have a larger, which of those 2 gradient vectors will have a larger magnitude. So first, let's estimate our function values. So first of all, let's call our function f, just for notation. Let's estimate these function values. So first, let's find our points. So 0.51 is going to put us right about there. And what I'm going to say is that I see a contour line where the value is 0, a contour line when the value is 2, and my point is about halfway between those. So I'll make a reasonable estimate and say the function value there is about 1. That's the first point. The second point, negative 1.5, negative 1.5, that's going to put me right about there. Okay. And once again, I'm in between 2 contour lines with value negative 4 and negative 6. So I'm going to estimate and say that my function value is about negative 5. Again, these are just estimates. So those are reasonable values. Okay. Next, we're going to draw a vector in the direction of the gradient. So what we know about the direction of the gradient is that it is perpendicular to a level curve. Now, we didn't have the good fortune of either of our points being on a level curve, so we have to estimate. So what I would say is that if looking at our first point, 0.5, 1, if this level curve is like this and this level curve is like this, then a level curve to this point, maybe it looks something like that. So my gradient vector needs to be perpendicular to that. And in particular, that gives us 2 different directions, this one and this one. But one of these points in the direction of decrease, the other one points in the direction of increase. And we know that gradient vectors point in the direction of greatest increase. So there is my gradient vector. And again, it's an approximation. And we do the same thing at the second point. Now in this case, these 2 contour lines are very nearly straight and very nearly parallel. So it's much easier to estimate what a contour line through that point would look like. And once again, both of those would be perpendicular to the contour lines, but we only want the one in the direction of increase. So that is our gradient vector. Or that is a vector in the direction of the gradient vector. Next, at which point is the magnitude of the gradient larger? Well, what do we know about the magnitude of the gradient? It is the magnitude of the largest rate of change. Well, how can we estimate rates of change from a contour map? In particular, when will rates of change be larger? When will they be smaller? Well, contour lines tell us what the values are, so we're going to be increasing in value the closer the contour lines are to each other. So we can see that at the first point, the contour lines are more spaced out. At the second point, the contour lines are more closely packed together. Therefore, at the second point, we will have a larger rate of increase, and therefore, that will have a larger gradient magnitude. And there's your solution.